this function and then decide upon discontinuities, if any. Okay, very good. So now I don't remember if you took pre-calculus anytime in the past or did not. Okay. Well, when we graph the function 1 over x, this we have to know, even from algebra. We graph this. This is 1 over x. Now, when we change x into x plus 2, what type of transformation is that? What will that do to the function?
Are we going to the left?
Yes,
Okay.
because where is the vertical asymptote now? And that will tell you exactly which direction we're going. It is a -2, correct. So it's a left shift. So this branch will move here, and of course this branch will move here to get 1 over x plus 2. So I know exactly what to graph, right? But I'm also told that when x equals -2, the function is 1. I'm going to show the chart and everything as I always do, but I just wanted to give you the heads up. So when we graph 1 over x, this is the graph. When we graph 1 over x plus 2, it's just a left shift of 2 units, right? Because now obviously this has a vertical asymptote at -2. It's undefined at -2. So when x equals -2, we have 1, right? So what type of discontinuity is this? Well, first of all, I would say it's an infinite discontinuity because the function is undefined. So this function, I cannot connect in any way, shape, or form the branch with a point and this branch with a point. So there is a discontinuity of it's called infinite discontinuity. This is the case. So if you want to present the chart, which I think it's self-explanatory, the reason why I insist to present myself the chart is because I'm building on this chart later in the next chapters. So for me, this is a very useful method of presenting my material. And you will see how easy it becomes when we graph a function later, when we have the function in there, the first derivative and the second derivative. It will be very easy to read the chart. So, of course, this is what I have, -infinity to infinity. 0 must be in the chart, so -2 and 0. And this function is undefined. This one is undefined at -2, but it's defined in a different way at -2 with a separate branch, when in this case it's a point. Now I have to determine the limit from the left here. As x approaches -2 from the left, what is the limit? Limit as x approaches -2 from the left from 1 over x plus 2. What is that limit? Yeah, so you plug in a -2 and you get 1 over 0. You know it has to be infinity, -infinity, or d and e. So then you plug in -2.1. The denominator becomes negative. The numerator is positive, so the answer is negative. Well, we already have it here. You see it on the graph. Now the limit on the other side. Limit as x approaches 2 from the left, no, -2 from the right, of 1 over x plus 2. Again, is 1 over 0. But when you plug in -1.9, the top is positive, the bottom is positive, so it's positive infinity. Now, when you plug in 0, when x is 0, y is 1/2. And now the limit's at infinity. As x approaches infinity of this, what do you get? As x approaches infinity, limit 1 over x plus 2 as x approaches infinity is, of course. And limit as x approaches -infinity of 1 over x plus 2 is. So what does that mean? Two things. what does x equals -2 become? Since the limits left and right are infinities, is a VA. What does y equals 0 become? An HA at both sides. See, I'm not enforcing a chart on you, but the chart is extremely valuable. Because if you forget something like this, in the chart you will figure out. So how do I know I have all the information? Because I see everything. I see the limits at infinity. I see the limit left and right. I see the function value there, and I have the x-intercept, the y-intercept, forgive me. So everything is there. I have the vertical and the horizontal, and I'm building on this chart in the next chapters. So disregarding the chart, I think it's a mistake. Very good. Anything else? So I would say discontinuity of type infinity, and the function has a vertical asymptote at -2.
So the next section,
Yes.
number 49 on page 142, that takes us to the next step.
So you said 49 on page 142.
So it's find a formula for a function that satisfies all of the following limits, or all of the following conditions.
You said what page again?
Oh, 142.
Oh, I was looking at 152. Sorry. 142 problem? 49. 49. Where are you? 49. Yes. So let's look at that. 49 on page 142. Find a formula for a function f that satisfies the following conditions. So limit x approaches plus or minus infinity of f of x is 0. Limit x approaches 0 from f of x is -infinity. F of 2 is 0. Limit x approaches 3 from the left of f of x is infinity. And limit x approaches 3 from the right of f of x is -infinity.
So I made the chart. And
Yes.
I graphed it, but then I realized
They were not asking you to
they
graph.
actually want a formula.
That's fine.
I have no idea.
Okay. Okay. Very good. So I will create the chart. Why?
Because you're going to build
I want to summarize. I want to summarize the information. You will see what happens in the next chapters. You will have material that you worked on or stuff that you worked on 3 pages. How would you put that together? So that's why I recommend this. So here's my chart, right? So the question is asking, find a formula. So there is more than one correct answer here. It doesn't say find the. It says find a formula for a function that satisfies the following conditions. Okay. So at positive and negative infinity is 0. I know from here that y equals 0 is a horizontal asymptote. Limit from either side of 0 f of 2 is 0. So if the limit from 0 from either side is negative infinity, then the function cannot be defined here. Unless it's defined like the other function before was defined separately. But it doesn't say that. Okay? So this is done. So y equals 0 is an HA on both sides. 0 from the right, so it appears that x equals 0 is a VA. F of 2 is 0, fine. And where is 3? Okay, I'm going to have to move my infinity further to the right because I have to insert that 3 in there, right? And I don't have room. So I'm going to insert 3. That's the last thing I need to put in the chart. So I have 3 from the left is infinity. 3 from the right is -infinity. So x equals 3 must be a VA, no doubt about it, because otherwise I will not have this condition. So I'm going to put 3 here just because it's still wet. So to the left is positive infinity, to the right is -infinity. Okay, so let's see. f of x. I'm just going to write in pencil so I can erase and come back and make my changes. So this 1 over x, when x is less than 0, okay, that's one option. I didn't finish, so hold on till I am done. So 1 over x for x less than 0 goes to 0, and less than goes to negative infinity. Perfect. This part is fine. It's undefined at 0. Fine. Now to the right hand side, I can put it as x plus, so they're both in negative infinity. In order to, okay, very good. For 0 less than 3, I'm checking my work now. As x approaches 0 from the right, 0 from the right is negative infinity. So between, I'm going to put 2 here. Then I'm going to say it's 0 when x is 2. Okay, now x equals 3 is a vertical asymptote. So I have 1 over x minus 3 for 2 to 3, and the infinity 3 to the left. So 3 to the left and 1 positive infinity. Okay, so 3 from the left will be 2.9. Yep, that's good. Undefined at 3. And on the other side, I want 0 here, and I want, yes, 1 over x minus 3 as x is greater than 3. Okay, let's give it a shot one more time. We are checking everything. So I have to show that the limit as x approaches negative infinity is 0. As x approaches negative infinity of this is 0. Done. Have to show that the limit of the left to the left of 0 is negative infinity. Limit from to the left of 0 is negative infinity. So this is 0. Plug in negative 0.1 is negative infinity. Done. At 0, the function is undefined. I don't have 0 anywhere. Then on the other side, I have at 2 to the left-hand side. No, I'm on the right-hand side. Yeah, I already did that. Okay, so I'm here now. So it's 0 when x is 2. Now I'm here. On the left-hand side of 3, like a 3.1. 3.1 minus 3. 3.1 minus 3 is, no, I don't need that. 3.1, no, it's 2.9, of course. I'm still correct. So with 2.9 is negative 2.9, it's 0, of course, in the denominator, but with 2.9, I have negative with negative, it's positive. Done. It's undefined at 3. So now on this side, I have 1 over x minus 3. To the right-hand side of 3, like 3.1, will be negative 3.1. Yep, 3.1. 3.1 minus 3 is positive with minus in front. I can condense this and say union, or just also x greater than 3. Or I can say x greater than 2 instead of writing all this, or x greater than 2 with x not equal 3. Instead of putting it as 2 branches, I can just say condense this into 1. Negative 1 over x minus 3 when x is greater than 2 but not 3. I can play with it and come up with other situations as well. Is this clear? This is not the only option. You can come up with something else as well.
So I've got the solution book.
Yes.
So that I can check them. So I looked at the solution book, and it just has like a ratio of binomials. Maybe
That's
so-
true too.
Yeah,
That's what I said
yeah.
when we
I
started.
Yeah, I just don't know how to build those.
It's
I guess.
not
Okay.
the only option.
Okay.
It just says find a function that fulfills the given conditions. Our function fulfills all conditions. And as x approaches infinity is 0. As x approaches infinity of this is 0. So you can have 1, 2, 3, and 4 branches. As long as you say, or you write for these two, x greater than 2, but not 3. Very good. Other questions? Can we go over this? Okay. How do you show that a function has or does not have a horizontal asymptote? What do you do? Very good. So you have to find limit of f of x as x approaches infinity and limit of f of x as x approaches negative infinity. And then what? What if the answer is
If it's a number,
exactly
then you have an asymptote.
right, the horizontal asymptote?
If it goes on to infinity, then you don't.
Exactly. Answer a number, y equals that number, horizontal asymptote. Otherwise, not a horizontal asymptote. Very good. How do you, yes? Oh, yeah, I'm sorry. Sorry about that. How do you show that a function has or does not have a vertical asymptote? First of all, what is the requirement for a vertical asymptote? Before you even talk about limits.
The point doesn't exist.
The function is undefined. Not that the point does not exist, because here, for example, the point existed. Right? Here the point existed, but still the function has a vertical asymptote there. So f of a is undefined. F of a is undefined. Then you have to find what? Limit of f of x when
X approaches that point from the right.
very good, and limit of f of x as x approaches a from the right. What has to happen?
They have to be equal, and they also have to.
No, they don't have to equal.
They
The
have
left
to-
and right don't have to equal. At least one of them must be
Plus or minus infinity.
exactly, exactly. So at least one of these limits is plus or minus infinity. Very good. Can a function, I meant to say the graph, can the graph of a function cross a vertical asymptote? No, the graph cannot cross it. It may be defined like this. It may be defined like this, but the function itself can never cross a vertical asymptote. No. Because the function is undefined there. F of x is undefined there. What about a horizontal asymptote? Can a function cross a horizontal asymptote? Yes. Yes, it can cross a horizontal asymptote. Because the horizontal asymptote has meaning only at the very end, not in the middle. But I can graph a function by showing a piece here and a piece there. I mean, a horizontal asymptote. What about a slant asymptote? Yes, it can. Yes, a function can cross, the graph of a function, of course, can cross a slant. We'll go back to slant asymptotes when we graph these functions by hand. How many indeterminate cases have you seen so far?
3.
Yes. 0 over 0 infinity over infinity, and infinity minus infinity. We will continue adding to that list. Can a function have more than one horizontal asymptote?
Yes.
How?
When the limit as x approaches positive infinity is equal to the limit as x approaches negative infinity, but they're both constant.
Exactly. So on one side I can have positive 4, on the other side I can have negative 4. So the function, the asymptotes will look like this. In my example, this is y equals 4, and there is no need to extend it to the left. And this is y equals negative 4, and there is no need to extend it to the right, because the function values approach here, the function values approach there. Another example would be, very important example, will be a function called arctangent. Excellent. So here's an example, f of x, arctangent x. What are the limits of f of x, arctangent x? To infinity
Pi
over,
pi over 2 and negative
yes,
pi over 2.
and negative pi over 2. So how? This is the situation. Why? Is because the function values approach different signs on different sides. Right. State both definitions of the derivative of a function at a point. So I would like us to start there, because I only showed you an example. So
These are two different formulas?
Yes. Yes. So there are two ways of presenting. I only showed an example. We did not really go into details. So f prime of a has two possibilities. F prime of x has only one definition. But f prime of a has two possibilities. F prime of x, we'll talk about it today. But f prime of a has two options. So f prime of a, first of all, what is it? It's the derivative of a function at a point. This is f prime of a. It's the slope of the tangent line to the graph of that function at that point. It's the rate of change of that function at that point. And the notation is f prime of a. Okay, we read it f prime of a. F prime of a.
So is that a little 1?
Yes, it's like a 1, but it's not 1. It's just 1 bar. 2 bars will be the second derivative. 3 bars will be the third derivative, and so on and so forth.
So it's like a little hash.
Yes, yes. So the notation is like this. F prime. The second derivative is this. The third derivative is this.
Okay.
The fourth derivative is this. You can consider it Roman numbers. Now, sometimes this is denoted by this. It doesn't mean that it's f to the 4th power. It's the 4th derivative. The nth derivative will look like this. So we cannot really continue with Roman numbers, because that will be huge, right? So 55, right? So I can write f to 55, which means the 55th derivative of function f. If the function happens to be differentiate.
I can't say anything else.
Okay. So let's come back to f prime of a. Differentiable. Okay, I couldn't put my tongue on it. So differentiable. If the function is differentiable 55 times, if it has a derivative, in other words, when I differentiate it at 55th time. Okay, so there are two options here. One option is limit as x approaches a from f of x minus f of a divided by x minus a. We know this because we have point P and point Q, right? So let me remind you of this. Here it is. This is point P. This is point Q. Point P has x f of x. Point Q has a f of a. So f prime of a will be limit as x approaches a from f of x minus f of a over x minus a. So this is one option. The other option is with limit sh approaches 0. Instead of writing f of x plus h minus f of x over h, I will write f of a plus h minus f of a. So these are the two definitions. You're not forced to use one over the other. As I mentioned last time, some functions work faster with this, some work faster with that. Some are better with this definition, some are better with this definition. But you're not forced to use either one. They mean the same thing. So this is the meaning of the first one. Limit as I bring this time p next to or close to q as x approaches a. So I'm moving p closer and closer to q. So f of x minus f of a over x minus a, that's the limit as x approaches a. What will this be? Same thing like we looked at long time ago. So this is p, and this is q. So now we have, this time is p, which is a comma f of a. And this is a plus h comma f of a plus h. Exactly what we did a month ago. So now the slope will be f of a plus h minus f of a over a plus h minus a, which is h. Exact same thing, written slightly differently. Okay. Any questions? Any questions? But the derivative function, so this is the derivative function. We'll talk about it today. But that one has only one definition, and you know it. I like to write it since we're writing everything on this form. Can anyone give us the definition of f prime? Everyone knows that. You may have not thought of these two till we put them in writing now, but f prime, everyone knows from day one. I'm ready. It must be a what? What do I start with? Of course. Of what?
X approaches
As the secant line approaches the
Right. So how do I write it? Mm-hmm.
the m under
Yeah, we passed that. You're right. You're on the right track. How do I write it? It's been in your notes for a month. Of the difference quotient, right?
Like just a general standard definition or the geometric definition.
I started with the limit, so right? I have the limit. It must be the same thing, right?
Yeah.
x plus h minus
F of x plus h minus f of x over when? Exactly. This is what we've known for a month. We did not know this notation for a month, but we knew that this is going to give us the slope of the tangent line at any point x, any point p with some x. So this is, we didn't know, again, we did not know the notation, but that is a derivative function. Very good. Okay. Any questions? So this was developed on this. So this is what we learned first, and now these are two little deviations. Okay, I do have a little quiz for you. I do or I don't? I guess I do. Well, we have to think a little bit. So this is like your classwork, right? Because it's open notes, open book. So I am hoping that between classes we do the notes, we work on some problems, right? This is again open notes, open book. Do we need more time? Okay. Almost finished?
Do we have to graph it?
No. You don't have to graph it. Thank you. Thank you very much. Finished? Thank you. Finished? Okay. But you cannot listen to anything you want, so. All right.
So why do I?
I know, I know. discussed, I wanted to see all your proofs, right? So if it's a horizontal asymptote, then you have to determine the limits. And if it's a vertical asymptote, you have to determine the limits, right? Okay. Do I need to go over this right now, or? Okay.
You might start running down the hall.
Say it again.
You might start running down the hall.
That's fine. So I look at this function and I see that this has 2x squared plus x minus 1, and the denominator is x plus 2 and x minus 1. I already know that x cannot be negative 2 and x cannot be 1. So they appear to be VAs, but I have to find the limit as x approaches negative 2 from the left of 2x squared plus x minus 1 over x plus 2 x minus 1. And I have to find the limit as x approaches negative 2 from the right of the same thing. Also limit as x approaches 1 from the left of the same thing. So this is no longer sufficient to say it's a vertical asymptote. That's not enough. You have to find the limits. And for horizontal asymptote, I have to find the limit as x approaches infinity from 2y squared plus x minus 1 over x squared plus x minus 2. And the other one as x approaches negative infinity. In this case, it's not going to make any difference if it's infinity or negative infinity. The function will have only one horizontal asymptote. Oh, I wrote y. Why did I write y? Okay,